Hello everyone, and welcome to 7th grade Math Module 2, Rational Numbers. In this video, we're looking at Lesson 2.11, Develop Rules for Multiplying Integers. Our learning goal is to make sure we can understand and apply rules for multiplication of integers to solve problems. This will help us to master Standard 7 NSA 2, apply and extend previous understandings of multiplication and division of fractions to multiply and divide rational numbers. In order to use these multiplication rules, we need to remember that multiplication is just repeated addition, so we can use what we already know about adding integers to help us determine our rules for multiplying integers. We have here a coordinate plane that we're going to use to try to find the rules for multiplying integers using our integer card game. Remember, to find the score in our integer card game, we add the values of our cards. Our x-axis is going to represent the number of cards that match, and our y-axis is going to represent the value of our cards. So for example, if I had 3 matching cards that had a value of positive 2, I know that my answer for my score would be 6. I can get that either by adding 2 to itself 3 times or doing 2 times 3. So quadrant 1 should be relatively easy for us to fill out because it's just a multiplication table. 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, so on and so forth. So we find that if we had the card of 1, the number of times that we have the card would get us our answer to multiplying 1 times how many of those cards matched. If we did it with 2, the 1 2 card would be 2, 2 2 cards would be 4, and we continue counting up by 2s. For 3s, we'd count up by 3s, 4s count up by 4s, and 5 count ups by 5. This is the basic multiplication you guys are used to doing. So this quadrant 1 here represents just picking up positive value cards. Well, what if we go to quadrant 2, and instead of picking up our cards, what if instead we are removing our positive value cards from our hand? Well, let's say we removed a positive 1. If we removed one positive 1, our score would go down by 1. So 1 times negative 1 is negative 1. If we removed 2 1s, our score would go down 2. Removing 3 would make it go down 3, and so on. So positive 1 times a negative number equals that same negative number. If we do the same thing with a positive 2 card, we find that as we are removing the cards, our score goes down by 2 each time. The same with 3 by 3, 4 by 4, and 5 by 5. So our similarities with quadrant 1 here is that the absolute values of our products are the same. The only difference is that all of our products are negative. Let's try looking at quadrant 4 next. In quadrant 4, we have a positive number of matching cards. We're still gaining cards, but this time we're going to be gaining some negative cards. So if I gain a negative 1, my score is negative 1. 2 negative 1s make negative 2, and so on. If I do the same with negative 2, my score is going to decrease by 2 for each copy of that card I have. The same with negative 3, going down by 3s, 4 going down by 4, and 5 going down by 5. So we see here that quadrants 2 and quadrants 4 have all of the same products with their pairs of numbers, and the factors that we multiplied had different signs. So this quadrant here again was picking up our negative card values. So then we're left with quadrant 3, our quadrant that has all negative numbers. And this quadrant represents removing our negative value cards. So let's say whatever my score was, and I removed a negative 1 card. We know from our subtraction rules and from our subtraction rules that when we take away a negative, we can do keep, change, and rewrite that subtraction problem as adding a positive. So when I take away a negative 1, I'm left with an increase of my score by 1. If I take away 2 negative 1s, my score increases by 2, and so on. I find the same pattern if I take away a negative 2 card. My score will increase by 2 for each negative 2 I take away. My score will increase by 3 for each negative 3 I take away, increase by 4 for each negative 4 I take away, and increase by 5 for each negative 5 I take away. So it turns out that quadrants 1 and quadrants 3 all have the same products, and their factors all had similar signs. When we had negative times negative, we got a positive, and positive times positive made a positive. So the rule that we can use to sum up what we found on this table is when we are multiplying integers, if we have the same signs, our answer is going to be positive. And if we had different signs, our answer is going to be negative. The absolute values of our answers are the same we would get if we were just multiplying regular positive numbers. Now we're going to use some problems and try to think about what they have to do in the real world while using our multiplying rules for integers. So first I have negative 3 times 5. With multiplication and with integers, I tend to like to think of money. So I can look at my first factor of negative 3 and think of that as paying $3. I look at my second factor and I think about how many times I'm doing that. So I could think of this as paying $3 on 5 different days. Using my rules, I know that 3 times 5 is 15, and because my signs are different, my answer should be negative. And this makes sense, because if I pay $3 on 5 different days, I would end up paying or losing a total of $15. You can try doing the same thing with B and C. Try both to use our multiplication rules to find your answer, and try to write a sentence that would explain what this problem means in real life. You can pause the video now and try on your own. How did it go? I can think of negative 6 times negative 3 as first the negative 6 being paying $6. But how do I represent it not happening 3 times? Well, I could say that I don't pay $6 on 3 different days. 6 times 3 is 18, and because our signs are the same, this is positive. And that makes sense with this situation, because if I don't pay money, $6 on 3 different days, I have saved money, and in this case, I would have saved $18. Let's try with 4 and negative 7. I can still think again of my first factor 4 as an amount of money, but this time because it is positive, instead of paying the $4, I would be earning the $4. The negative 7 for my second factor would tell me that I'm not doing that 7 times. So I can think of 4 times negative 7 as not earning $4 on 7 different days. The absolute value of 4 times 7 is 28, and because my signs are different, my answer should be negative. And that makes sense with my situation, because if I do not earn $4 on 7 different days, then I have missed out and do not have the $28 I could have earned. What does this video make you wonder about multiplying integers? Write your questions down so you don't forget them. Then you can try to find answers online or ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learned from your failures, then you succeeded.